Hello guys, in this video we'll be learning about designing a full adder using your demultiplexer. First, let us look into the symbol of the full adder. This is the symbol of your full adder where you have three inputs A, B and C in, two outputs sum and Cout. And this is the truth table of your full adder. The three inputs to the function ABC are connected to the select lines of a 3 to 8 demultiplexer. The 8 outputs of the demultiplexer run horizontally into the schematic diagram and each is labeled with the input values for which the output will be high. So when the inputs are 0, 0, 0, the top demultiplexer output will be high and all other demultiplexer outputs will be low. When the inputs are 0, 0, 1, when A, B are 0 and C in is 1, the second demultiplexer output will be high and so on. The demultiplexer outputs control a matrix of NFETs pull-down switches. As you can see in the figure, the matrix has one vertical column for each output of the truth table. Each switch connects to a particular vertical column to ground, forcing it to a low. When the switch is on, the column circuitry is designed so that if no pull down switches force its to value 0, its value will be a 1. The value on each of the vertical columns is inverted to produce the final output values. As you can see that there are two inverters at the end. So how do we use the circuitry to implement the function describing by the truth table? For any particular combination of input values, exactly one of the decoder outputs will be high. All the others will be low. Think of the demultiplexer output as indicating which row of the truth table has been selected by input values. All the pull down switches are controlled by high demultiplexer output will be turned on, forcing the vertical column to which they connect low. For example, if inputs are 0, 0, 1, the demultiplexer output labeled 0, 0, 1 will be high. This will turn on the circled pull down switch, forcing the S vertical column low. The Cout vertical column is not pulled down, so it will be high. After the output inverters, S will be 1 and Cout will be 0, the desired output values. But changing the location of pull down switches, this read-only memory can be programmed to implement any 3 input 2 output function. For read-only memories with many inputs, the demultiplexer have many outputs and the vertical columns in switch matrix can be quite long and slow. We can reconfigure the circuit slightly so that some of the input controls the demultiplexer and the other inputs are used to select among multiple shorter and faster vertical columns. This combination of small decoders or demultiplexers and output muxes is quite common in these sort of memories. Everyone has a big question. What is the main difference between a decoder and a demultiplexer? A demultiplexer will always have one input signal, whereas a decoder can have many input signal. Thank you.